So now we are gonna start with the next chapter, that is your chemical kinetics. Okay, so for any chemical reaction, that is, suppose you have A moles of the A combining with the B moles of B, forming your product, that is C moles of the C plus the D moles of D. Suppose this is your chemical reaction you are having it. Chemical reaction means the reactants they are combining and the new product is being during the formation, that is chemical changes occurring when this reaction is taking place, right? So this is your chemical reaction. So in this chemical reaction, if I want to find that how much amount of the product has to be formed, that is basically how much product is being formed, that is about the amount when we talk about. So this about this at how much amount of the substance is being formed, about this we study in the branch, that is your mole concept. All this we have already covered, that is during a chemical reaction how much amount of the substance was being formed, that we cover under the topic, that is your mole concept. Now for the same reaction, if you want to find it, that will this reaction will be spontaneous or it is going to be feasible reaction or not. That is, spontaneous means once we have initiated, it will continue on its own. That is to talk about the spontaneity or the feasibility, or the feasibility of a reaction. About this we study in our chapter, that was your thermodynamics, that is using the by calculating the Gibbs free energy value for this particular reaction, that is delta G, at the constant temperature and the pressure. If it is coming out to be less than equal to the 0, then the reaction we call it is your less than 0, it is your spontaneous process. Or the entropy of this particular reaction, if we are carrying it out, and if it is coming out to be greater than the 0, then also the reaction we can say it is your feasible or the spontaneity. That is to find out that how much amount of the product is being formed, and to find out that whether this reaction will take place or not. All these things we have already covered in the two different branches. Now for this chemical reaction, if I want to find out that in how much time this reaction will be completed, that is the rate of the reaction or the speed of the reaction we want to find it out, that is what is studied under our branch, that is the chemical kinetics. Okay, so now we have to find is that the time taken to complete the reaction, is studied, or to find out the, in fact to find out the mechanism of the reaction also, the mechanism of the reaction. This is studied under your branch, that is your kinetics. Okay, from the name also of it, you can see it, the word is chemical kinetics. It is made up of the two of the words. The word is chemical, which comes from the word that is your chemical reactions, that is during the chemical reactions, and the kinetics word basically it is taken from the motion. So in the physics also you might learn about this, like the term kinematics or the kinetics term, which is related to the motion. That is, we are talking about the speed of the something, right? So here, since we are talking about the chemical reactions, so the chemical kinetics means we are talking about the speed of the reaction. Okay, or you can say is speed of the reaction, or we can call it the rate of the reaction. So basically chemical kinetics is the branch of physical chemistry. Chemical kinetics is the branch of physical chemistry, in which we talk about the speed of the reaction, or the rate of the reaction. Now here a new word you are encountering, that is the rate of the reaction. So we have correlated this term, that is the rate of the reaction, to the speed of the reaction. So how do you generally define the speed of something? Like suppose you are moving it and you are covering, suppose from the point A you are going to the point B and you are covering a certain distance, that is suppose D, and the time that you are taking is the T time you are taking to complete this much distance. So how you are going to define the speed in this case? It will be the distance that you are covering and the time that you are taking. So this distance that is being covered upon the time, this defines your speed of the particular moving object, right? So now we have, since the chemical reactions, so in that the rate of the reaction. So basically a chemical reaction is taking place. That is, suppose your reactants, they are combining and the product is being formed. So what is going to happen in this? Initially, when you are starting the reaction, that is at time t is equal to 0, you will be having certain amount of your reactants. Suppose A is the amount of the reactant we are having it. Or suppose the single reactant is being converted to the products only. So here you have the certain amount of the reactant you will be having and no amount of the C and D will be present in the reaction mixture at the starting of the reaction. Right? Now as the time it will proceed, what is going to happen? Certain amount of the A is gonna be converted to the product, that is C and D. So what is actually happening? The amount of the A that we are having is decreasing. Suppose X amount of the A has dissociated and the Y amount of the C is being formed and the Z amount of the D is being formed. So what actually is happening? There is gonna be the change in the concentration of the reactant as well as the product is taking place. How you can define this? Initially the reactant we are having as the concentration A of it we are having, as the time proceeds or we start the reaction, the A is converting to the B, converting to the product, that is your C and D we have written. So certain amount of the A is breaking and the certain amount of the C and D is being formed during the reaction. So concentration of the A is basically changing, that is it is decreasing, or the product also you can see initially at the time T is equal to 0 amount of these we were having, but after the reaction Y and the Z amount of it is being formed. So what actually is happening? The change in the concentration is now taking place. While discussing about the motion of the any particle, it is the distance that is being covered upon the time that is being taken. So similar way, the rate of the reaction is defined as the change in the concentration upon the time taken. So how do we define the rate? That is change in the concentration. This may be with respect to the reactants as well as with respect to the products. So change in concentration of the reactants or the products upon the time taken. Here from the time t is equal to t time we have gone. So this much time interval is the time that is taking place. So this is gonna define your rate of the reaction, which is change in the concentration upon your time taken. Okay. So now what is gonna be the units of the rate of this reaction? So now we are gonna look upon units of the rate of the reaction. Okay. So rate of reaction is, so I'm writing the rate of reaction like ROR. This is the short form of it we are gonna make use. This is equal to change in the concentration upon the time taken, right? So concentration we generally take is in the terms of the molarity. So here you have the molarity in the terms of the molarity upon the time. Now what is the molarity? Molarity is nothing but your concentration term, that is number of the moles of the solute upon the volume of the solution in the liters. Volume of the solution in the liters, right? So now how do you calculate the number of the moles? So number of the moles we have seen that we can calculate is like the given weight upon the molecular weight of it. So this is how the molarity can be calculated and this is your concentration.